Okay, we're going to cover the high points of DHCP. DHCP stands for Dynamic Host Configuration Protocol. It was defined in RFC 1531 and updated by some others. I've listed a couple, there might be more after that. It basically provides a framework for passing configuration information for hosts on a TCP IP network. We should all be familiar with DHCP at this point in our studies, basically how we get IP addresses, right? It is based on the Bootstrap protocol that was used earlier that could have been used to give out IP address information. The main difference about the Bootstrap protocol was that it had to be configured for which host got which address. With DHCP, it is capable of automatic allocation of reusable network addresses and additional configuration options. So here's a question for you. How can a machine with no IP address communicate on the network to get an IP address? So basically we need to get an IP address so we can participate on the network, but we don't have an IP address. So it's kind of a bit of the chicken and the egg problem. Well, the way that works is we use broadcast packets. Basically we send out a broadcast request that says, hey, is there any DHCP servers out there? And then that DHCP server will reply to the broadcast address saying, oh, hey, I'm a DHCP server, and it works that way. We're going to actually look at a packet capture in a minute. DHCP uses ports 67 and 68 UDP ports. It uses low number ports for both the client and the server process, and that's different than what we're used to. Oh, how is that different than what we're used to, and why is that different than what we're used to? Well, the how is that different? We're normally used to a client using an ephemeral port, which is a high number port, right? We normally see a very high number random port as a source port. In this case, when we look at the capture, we'll see the client uses source port 68 and the server uses the fixed port 67. Well, in this case, we use the low number port to avoid potential confusion. Imagine a scenario where if the client used a high number port and sends a DHCP request, we just said that the server sends back a broadcast message back to the client. Well, if the client had picked some random high number port that some other client on the network had just happened to be using that other port, that same port number, then that other client would have received a reply, the broadcast reply. That other client would have tried to process that frame and would have been confused. So that's why we do that. DHCP options, we use those to give the host some additional information. A place you may have seen that is if you've taken any of the IP phone classes. Lots of times you give the phones a different, a certain option to tell it where to download its config file from or something like that. Here are the DHCP messages you might expect to run into if you're looking at the traffic. DHCP discover, the client broadcasts to locate available servers. DHCP offer, the server sends the client a response. Request, the client sends a request officially accepting the address that was given, and then the server will act that or possibly knack that. And then the client can also send a decline if it doesn't find the parameters to be valid, or a release. If you get done with the address at the end and you release it, you can tell the server that address has been released. A DHCP reservation, we normally think of DHCP as being able to give out dynamic addresses, but we can also use a DHCP reservation to bind a particular IP address to a host based on its MAC address. So in the configuration, you will specify the MAC address and what IP address it should get. So then even though the host is using DHCP protocol, it is not getting a truly dynamic address. It's getting a fixed address that gets assigned to it by DHCP. You must configure the server to support that. You have to put the MAC address and the IP address on there. And it's useful for hosts that need a fixed IP. Say, for example, you have a server that you want to have the same IP address every time, but you don't want to set it statically. You can do that with the DHCP reservation. Another concept we need to be familiar with is the DHCP relay agent. Basically, DHCP uses broadcast requests, right? So does that mean that we need a DHCP server on every segment of the network? Right, that'd be a lot of servers we would need. Well, no, we don't need to have a DHCP server for every segment. What we do is we configure a DHCP relay agent on an interface on that segment, and normally it's on the router interface of that segment. And basically what it does is it will listen for those DHCP requests, the broadcast request, and any DHCP broadcast request it gets, it will forward it to the DHCP server, and the DHCP server will send those packets back to the relay agent, and the relay agent will broadcast them out onto the network so the client can get their addresses. The DHCP server must be configured for each subnet it needs to supply information for. So basically, the term you normally hear related to the information for a particular subnet is the scope. So the server must be defined, have a scope defined for each subnet that it wants to provide information for. So summary, based on BootP, it can be used to give dynamic or fixed IPs via reservation, IP reservation for the fixed IPs, and it supports options to provide additional configuration information to the client. So that's about it for the slides. I have a capture file we'll look at. Basically, it's a capture file I had that only had DHCP packets in it. If you look at what we have here, we see that we have the first thing we see in the capture is a release, because I had an IP address when I started capturing. I wanted to get rid of it. So we have a release, right? The next thing we see is when I requested a new IP address. If you look, the source IP address is all zeros. The destination IP address is a broadcast MAC address. If you look at the layer 2 information, the frame information, it has the actual source address of the interface, but the MAC address is also the broadcast MAC address. And it's a DHCP discover. Next, we have the server sending a broadcast request, a broadcast packet back, the reply of a DHCP offer. And then the client, again, will send a broadcast packet that is a DHCP request. And then finally, the server will act that. So you may be wondering, why does it do discover, offer, and then if it's already done those two steps, why does it send back a request? Well, it does a discover, and it may get answers from more than one server. So if there were more than one server on this segment, then I would see multiple DHCP offers. And then the request is how the client tells the particular server it's accepting the address from, that it's going to accept the address, and then those other servers will hear that the client is accepting some other offer, and it'll know that it's not going to accept this offer. And then the server sends back an ACK just saying, okay, everything's good. You can indeed use that request. So that's about it for the overview of the important things we might need to know about the DHCP protocol. We'll actually configure our own DHCP servers in the lab, so it should be a lot of fun.